What is microservices architecture? Answer. Microservices architecture is an approach where an application is divided into multiple small independent services. Each service has its own business logic. It owns database and independent deployment. Communicate through REST APIs or messaging system. Unlike monolithic architecture, every services can be tested and deployment separately. Let's see example. Order service, inventory service, payment service, notification service. Each services works independently. Why companies use it? Easy deployment, independent scaling, better for isolation, faster deployment. Let's see difference between monolithic and microservices. Monolithic, single application, microservices, multiple small services. In monolithic, there will be one deployment, but in microservices, there will be independent deployment. There will be multiple deployment. In monolithic, shared databases, but in microservices, there will be separate databases for each service. In monolithic, difficult scaling, but in microservices, easy scaling. In monolithic, whole application affected if we are going to deploy any changes, but in the microservices, only one service affected. Let's see how do microservices communicate. There is two ways to communicate of microservices. First one is synchronous communication. Second one is asynchronous communication. Let's see synchronous communication. In synchronous communication, we use REST APIs and FAN client. Example, order service, payment service, and it provides immediate response. Order service will call the payment service. Okay. Let's see asynchronous communication. There is Kafka, RabbitMQ, and ActiveMQ. Let's see example. Order created, Kafka topic created. After that, it hits inventory, then generates notification, then analytics. No waiting for response. Let's see real example. In Swiggy, order services publish sentiment, notification services received it later with the help of Kafka, RabbitMQ or ActiveMQ, whatever we are using. Let's see what is service discovery. In microservices, IP addresses keep changing. Instead of remembering IP addresses, services register themselves in service registry. Let's see common tools. Spring Cloud, Netflix, Eureka. Let's see flow. Order services, register with Eureka. Payment services, ask Eureka. Gets latest status, calls payment service. Let's see benefits. Automatic discovery, load balancing, and dynamic scaling provided by service discovery. What is API gateway? API gateway is the single entry point of all client requests. Instead of calling every services directly, clients call the API gateway. API gateway forwards request to the correct service. Let's see popular tool. Spring Cloud Gateway, Kong, Nginx. We can achieve API gateway with the help of these tools. Okay. Let's see benefits. Authentication, routing, rate limited, logging, and security. Let's see what is circuit breaker. If one service is down, other service should not wait forever. Circuit breaker stops repeatedly failing request. It is stop calling again and again if any service is going to break. Okay. It will set a time duration after that will check if the service is active or not. Popular library resilience force. Let's see example. Order service payment service is down. Circuit breaker opens. Fallback response. Payment service temporary unavailable. Let's see benefits. Better performance, prevents cascading failure, and improves user experience. How do you secure microservices? Answer. Common security methods, JWT Authentication, Auth2, HTTPS, Spring Security, API Gateway Authentication, and role-based authorization. Let's see example. User login, JWT token generated. After that, client sends request. In the request, we will get token. Gateway validates token. After that, request forwarded. How do you handle distributed transactions? Answer. One transaction cannot span multiple databases easily. Instead, microservices use Saga pattern. There is two type, choreography and orchestration. Let's see example. Order created, inventory reserved, payment success, shipment created. If payment fails, inventory rollback. What is distributed tracing? Answer. One request travels across many services. Distributed tracing tracks the complete journey. Let's see popular two. Zipkin, Jagger, micrometer tracing. Example. Client hits gateway, after that order service, then inventory, after that payment, and after all notification. Every step gets trace ID. Let's see benefits. Easy debugging, performance monitoring, and error tracing. What challenges have you faced in your project? Let's see. Simple answer. In my project, I worked on Spring Boot microservices. Some challenges were timeout between services, database consistency, logging across services, authentication using JWT, Kafka message retry, Docker deployment, and API versioning. We solve these using Resilience Force, Spring Cloud Gateway, Kafka retry, centralized login, Zipkin, and Docker. Let's see real project architecture. Client hits API gateway checks. Client is asking for order service, inventory service, or payment service. After that, we hit Kafka notification service and email SMS. Thank you for watching. Please like, comment, and subscribe for more Java, Spring Boot microservices and interview preparation videos. Thank you.